We are going to look at trying to maximize or minimize the objective function z equals 4x plus 4y given these constraints. So we're going to actually set the objective function aside and focus on the constraints for a minute. We're going to try to graph each of these here. So the first one with x is less than 2. This is a line where all the x coordinates on that line are 2. So I want you to think of 2 points where the x values are 2. So I'm going to put the first coordinates to be 2. Oops. And then we can make up the y. I wanted to put a 0 there, and I'm going to go ahead and do that. And then you can just choose another y value here, maybe like 3. So when we go to graph those, we're going to graph these 2 points and then connect them with the line. So I've got 2, 3. There's my first point. And then I've got 2, 0. Now, when I get ready to connect them with my straight edge, I'm going to do that with a solid line because of the less than equal to. The equal to part tells me that when I connect these, it is with a solid line. Okay, now think about less than. Would that be to the left or the right of this line? The less than would be to the left. So what I'm going to do is I'm just going to take a colored pencil here and just lightly shade over on this side. This is x is less than or equal to 2. And it's not, like I said, I've shaded very lightly for a reason. I don't want to shade very dark. You're going to see why in just a second. Okay, let's do the next one, and that is y is greater than or equal to 3. So this one, you're going to have a line where all the y values are 3. And you get to just choose x's. It doesn't matter which x's you choose. Maybe this time I'll choose -2, and then maybe I'll choose 4. Okay, so let's plot those points. Starting here and going -2 would be left 2 and down 3. Put a dot there. And then 4, 3, we would go to the right 4. And then, oops, I counted wrong. Sorry about that. So left 2 and up 3, my mistake. And then here we would go right 4 and up 3. So I've got these 2 points I'm going to connect, and it is going to get a solid line again, and this is because of the equal to here. Okay, and now it's greater than or equal to, so do you think we're going to shade above it or below it? Yeah, you're right. We're going to shade above it for greater than. So what I'm doing now is I'm just going to take another colored map pencil and I'm going to shade above. And again, I'm doing this lightly because what I'm really interested in is the overlap. See that overlap region right there? That's the important part right now. Let's see if I can get a little bit of wider shot for you to be able to see out. There we go. Okay, so we've got one more constraint. And that is the one that's probably going to take us the most work. So we're going to take the 4x minus y is greater than or equal to -3. I'm going to have to do a little bit of work for it first. And what I mean by that is we're going to have to get y by itself. To do that, we're going to subtract 4x from both sides. So I'm going to subtract 4x. So these little pieces here, this is what I subtracted on both sides. Notice I did it on both sides of the inequality. So you can see that 4x minus 4x gives me 0. I'm left with -y is greater than or equal to -4x minus 3. And my next step, then I'm going to divide by a -1. Every term gets divided by -1. Notice that because I'm dividing by a negative number, I'm going to flip my inequality. All right, now I'm ready to graph this inequality. Okay, so we're going to start with a point. I'm going to choose an x value, a pretty easy one, like 0. I'm going to sub in 0 for x. We're going to see what we get for y. So I've got y, and I'm just going to use equal 4 times 0 plus 3. Well, 4 times 0 is 0. 0 plus 3 gives me 3. So I know the y-coordinate here is 3. Let's do one more easy value for x. I'll choose 1, and we'll plug it in. Y equals 4 times 1 plus 3. Just using the equation here to plug in my value for x. Then I get 4 times 1 is 4. That gives me 7. So here are my 2 points now on this line. We're going to plot them on the graph. So here we go. Starting here, we're going 0, 3. 0, 3, so I'll go 0 right or left, and then I go up 3. There we are, this point here. And then 1, 7. Start at the middle, go over 1, go up 7, 3, 6, 7. There we go. So I'm going to connect these 2 points. And notice it's going to be with a solid line again because we've got the equal to on it. And we're graphing less than. So that means we're shading below. This one actually leans a little bit to the right. So my shading portion, I'm looking for that. I'm going to do a different color here. I'm looking for where all 3 shadings overlap. Do you see it? It's that little triangle. And I'm doing intentionally shading a little bit darker so you can see it this time, where all 3 overlap. Now, to now use my shading to help me with the objective function, it's important that we see the coordinates for each of the corners. So I put those in black. And those coordinates, I'm going to find their coordinates. So this is 0, 3. And this one is 3, 3. And this one is, oops, I'm sorry, that's 2, 3. My mistake, not 3, 3. This is 2, 3. And this is 2, 10. Okay. Now, what do we do with those points? Well, I'm glad you asked. We're going to take our objective function, and we're going to plug in x and y. So I'm going to put 0 for x, and I'm going to put 3 for y. Let's see what we get. 0 for x, 3 for y. So 4 times 0 gives me 0. 4 times 3 gives me 12. So I get 12 here as my answer to my objective function. Let's do the same for 2, 3. I'm putting in 2 for x and 3 for y. So 2 for x and 3 for y. So order of operations, we multiply first. So 4 times 2 is 8. 4 times 3 is 12. So we get 20 here. One more. Put in 2, 10. 2 for x. 10 for y. So 4 times 2 is 8. 4 times 10 is 40. We get 48. Now that we've done all our calculations, if the problem asks us to what is the minimum value for your objective function, the minimum value is at 12, and it happens at 0, 3. If the problem asks us for maximum of our objective function, it's 48, and it happens at 2, 10. I hope this video helps you.